pleasure. Thank you so much. Congratulations to everyone who made it so far. It's been a very long day, and great to see the room being very full. Our very last event is a second roundtable where we have Sean and Barnaby co-moderating. Sean, do you want to kick us off?
Sure. Hello. So I'm Sean. I work on a Lighthouse at Sigma Prime. So I've been thinking about shorter slot times in the context of like, what can a beacon chain do and what can a beacon chain do in like the short term? And then also like, what is optimal? So I was hoping we could discuss, I guess short term, what can we do, sort of low hanging fruits for Ethereum today? And then what is optimal in a beacon context and what changes in a beam context? So yeah. Anyone have any thoughts? I don't mind starting us off. So I think today we have 12-second slots and we have some understanding of when messages are propagating and how long they take. And we have a sense that there is like slack in parts of the slot right now. So we could take like a very simple approach and just change a single constant, which is 12-second slot time, and keep the rest of the slot just like proportionally the same as far as when we're sending messages. And I think in there we could get to maybe 8 seconds, 6 seconds, relatively quickly, like maybe in the next hard fork. And I think that's maybe something that is a low-hanging fruit and something that's easy to coordinate around just because it's conceptually really simple. But on the other side of the argument, is changing the slot time in this way too invasive to do when we could maybe lay the groundwork for more optimally adjusting like how a slot is structured.
So the way I think I see the slot from one of the research articles is that there is basically a delta to the latency, and in a current slot we have 3 deltas. So if basically you assume that the nodes will process everything faster, generate block faster, and do aggregation faster, so you have basically 3 delta, and that for each delta in gossip sub you have about 6 hops right now, which could be maybe 600-700 milliseconds, and if it does 3 times that, so basically you have about 2.5 second slot. You can essentially have that, and but if you add proofs aggregation in non-untrained, that becomes 4 delta, so you can probably do a 3-second slot as well, I think so. But if we can actually drop the number of hops, for example, the strategy where you can form a grid and say that in 2 hops you can distribute the signatures to everyone. So basically you can then further drop it down. But question is, so how do we do that?
So I think an interesting thing there is like the number of deltas, like can we reduce the number of deltas? And there's been like a lot of talk lately about EPBS and delayed execution. And I think the idea there is to maybe overlap 2 of the deltas, where we have like the message that you want to attest to sent around first, which is maybe just a block header, and then you can send attestations for that, and as you start seeing attestations, then publish like the full block blobs, and in parallel attestations can be aggregated. So is that like the type of slot structure that makes sense? Is that like more close to what is potentially optimal? And then additionally, like it seems like it might fit in well with ZK proofs, where you send around the header while you're generating ZK proof, and then this overlap in time between like the vote aggregation, rebroadcast can also be done in parallel with like the proof generation and broadcast. So
maybe to ground the discussion with what are the proposals. I feel like everybody wants both to restructure the slot because we need like this delayed execution for proving and other things. Everybody also wants to shorten the slot time. I think at the moment there's debate around, do we shorten the slot time first and then do the restructuring, or do we do the restructuring first and then we shorten the slot time? And so one question I have, I'm a proponent of shortening the slot time first because I believe the effects are very, very important, and getting them sooner is very good, or at least like would be a huge win. But the question that's often come up is, let's say we don't restructure the slot first, and now we have like the current structure, so proposing, attesting, aggregating. The proposal that we have is to do 3 second proposing, 1.5 second attesting, 1.5 second aggregating. Is that doable? Like, we don't currently have hard numbers, and looking at Chaba's slide, it looks a bit optimistic to do 1.5 second attesting. And so I'm wondering, like, if you know, if you have better numbers, or if you would propose like a different partitioning of the slot, assuming we want to have, let's say, this 6 second target.
That sounds like a reasonable formula to me, like 3, 1.5, 1.5. But I don't know, tough to say. I think perhaps with some more of the P2P low latency toolbox, it's achievable. It seems like the simplest low hanging thing though would be like, it feels like there's about 4 seconds that you can just like take out a slot. You could still have the same proportions. And so that might be the easiest thing to like start with.
So once we have delayed execution, then we don't need to allocate extra time to block building, right?
Well, on delayed execution, like there's block building time is usually in competition with execution time. Like you have essentially like a lot of time for propagating, so you can have like more blobs, for instance. During that time, you could execute if you were receiving like the execution payload then. There's arguments for why builders might want to send the execution payload still as late as possible within that time. But after this propagation and potentially execution time, then you have execution time until the end of the slot, which needs to be both for the nodes to execute so that they can attest their view or propose the next block, and also for the builders to build the next block, either locally or externally. If you do externally, it's maybe even worse because then the builders have to build the next block and also participate in the auction. So there's like these extra trips. But yeah, so this might be like a small part of the execution budget, but yeah, essentially these are what these delayed execution proposals do. And that's also where you would have this extra proving time for the provers, because once they get the execution payload as an output, they can immediately start proving if they were separated from the builders. But as I understand, there's also like people making the argument that provers and builders shouldn't be separated so that they can start proving as early as locally they have the block, and that might be the best combination. So even if we were to like try to separate them in protocol, like the economics might be towards just integrating, because having the input locally allows you to just prove faster as well. But yeah, that's the tenor of the discussion, I would say. Yeah, Justin.
Bobby, is it correct that from your perspective, you think APS has been deprioritized in the short term? That's question number one. And question number two, do you agree with this take that the more we shorten the slot times, the more we reduce the slot to ping ratio, the more timing games become important, and therefore the more APS becomes important. And so if we're thinking about this end game kind of slot duration, we should actually assume that APS is there, because the timing games will become really prevalent.
Yeah, on APS, I think once you start thinking that shortening the slot time is a very strong objective, you start looking at things that stand in the way of doing that as potentially bad. And APS means that, yeah, you need an extra round of things. So you have like a beacon proposer, then an execution proposer. So it means like you're essentially doubling the distance between blocks. Oh, you say no?
Well, do we have an overhead of EPBS as well?
In EPBS, a little different because it's the builder role that we are taking out, and it's not the proposer role. And I think that actually makes quite a bit of a difference in the overhead of coming to consensus on one versus the other. Like we would want to have a full round of consensus on the output of the proposer in APS, which we don't really have on the builder in EPBS. Like we just have the PTC that's doing the availability committee essentially.
But can we have a PTC on APS?
Right. Yeah, that's an interesting question. I think we would still need to have. I'm not sure. Yeah, I want to think about it. But another reason that maybe was deprioritized is feeling that one of the main consumers of APS would be precons, and feeling again that shorter slot times address the need for more precons in the system, and so that made it maybe a little less load bearing. Yeah.
So on precons, the story that I've been telling is that if we reduce the slot durations in a very decentralized system like Ethereum, we're never going to get it less than, let's say, 1 second. And 1 second is just very, very long compared to Solana, for example. And so Ethereum is just going to always lose unless we embrace the pre-confirmations. And so I'm almost tempted to say, let's go all in on pre-confirmations because that's the only route that is going to lead us to win.
Sorry, it's different.
Back and forth. Yeah, I think that's an argument. I still feel like you can have pre-confirmation systems without having APS necessarily. Like APS just removes the role out and like specifies it in protocol. But I think it's possible, like if we are willing to eat the extra possible centralization pressure, that we just keep the role bundled with the validating role, and that might be a possible way of doing that. It just like removes some latency of having like two different parties in the same block. And then there's a question around timing games. I also like revisited a bit the thinking around this. I do think it can be a problem to like the consensus, but I also feel like there are interesting impacts of timing games, not to glorify them, but like for instance, Solana has the inverse leaderboard that we have. Like they celebrate people who play timing games very well, and the reason is because it shortens the transaction latency between the sender and the inclusion on chain, like the confirmation. Like when I send my transaction within a slot, it can go immediately from like the builder to actually being confirmed on chain. Like that's one thing that they find improving. You seem
I mean,
not
it's the
convinced.
opposite. Like timing game is all about delaying inclusion until the very last minute, so that you have more transactions and therefore more MEV.
Yeah, but if everybody is delayed by like 3 seconds, it means that whenever my transaction comes into that interval, it's just shift independent almost. But what timing games do is they force the block proposers to reduce as much as possible the latency between their block being produced and their block being like communicated to the network. Because the longer that latency is, the more MEV they lose during that interval. So it doesn't really actually matter like where the deadline is. What matters is just like the latency between the block being ready and the block being like sent to the network and confirmed. So yeah, I don't think we should go to that extreme. Like, but at the same time, I'm not completely convinced that timing games will necessarily like devolve into the consensus being completely broken on any reasonable time scale. So yeah, I don't know that we should be like so overly worried about them.
I have a bunch of grab bag of silly comments.
Well, one is, would you consider 7-second slots, because it sounded like 6 might be a little slow. 8 everybody knows is going to work, but if you looked at the one there, it was like 1.9 was where the 1.5s don't work. So it looks like you could probably just do 7 easily, and it's like not as nice of a number. You know, it's odd. But anyway, it's just worth mentioning. And personally, another question I would have had to the whole room is: does anybody so far? I haven't heard a lot of appetite of thinking that restructuring the block ahead of time is important. It sounds like if you can reduce 4, 5, 6 seconds just naively by just reducing it, does anybody here think that that's a bad idea? I haven't heard that yet, like the counter argument strongly. And then finally, yeah, it's like for this thing you mentioned, it's like with the timing games, it's like the difference between the bus leaving and when the doors of the bus close. So the bus always leaves at the same time, but the timing games make it so the doors of the bus close very, very close to when the bus leaves, and so more people can get in more often right at the end. So yeah, anyway, those were my random comments.
What do you mean restructuring the block?
The restructuring the
Like EPBS or
Ah,
delayed
EPBS.
execution.
yeah, these like changing how the like instead of
The
just
hot path.
yeah like how when different parts of block production life cycle happen.
I can leave a mic, but maybe I think it's the same answer to both your first and your second question, like why we wouldn't do 7 seconds and everyone is happy, or why we should think about restructuring. I think at the moment, there's just been a lot of work on restructuring, like and it's been talked about for a very long time. So there's a lot of code that's already ready. I don't think people are like blocking on 6 seconds, being like, oh, this is pushing it too far. Actually, people are fairly, so far, like in my interactions, I've been like fairly eager to explore whether it was feasible. I think the problem is just that the work of moving to these shorter slot times, whether like 10 or 8 or 6, just hasn't been done. So there's a lot of code that's still missing. It's not impossible to deliver it by Amsterdam, like if we are committing to it, but there's a lot of momentum behind the slot restructuring proposals. And so that's also an argument for going for the option that seems more readily available, I think. So yeah, it's not really a matter of like 10 or 8 or 6, in my opinion, at least.
I also have I'd like to comment explicitly about the quote-unquote, as far as the, and I forget which adverb you used, I apologize, but as far as the like, quote, just or simply or something.
True.
Right, so, and I'm not saying this is a bad thing, and I think that I am for reducing the slots times. I want to be clear, like, I guess, you know, as described by the people here. What I want to say is that it is not clear that it is a simpler option overall in terms of implementation, and the general idea is, and I want to kind of reframe this, and this is the reframing I've tried to, you know, push, but is to say, like, it doesn't, we could double the slot times, that would be approximately as hard as halving the slot times. And that is the key thing here. It is the hard thing is not shorter, the hard thing is variable. When people say shorter slot time, the way to read this is variable slot times. And that is what right now, a lot of the clients work in Gnosis, they work in minimal preset, and that's fine, 5 seconds, 6 seconds, we know it works. But the scenario is the test nets, dev nets have run faster per perf nets, right? It is a much less global change, actually, whether it's 7886 or 7732, some of the other proposals. Virtually all of them are in a lot of ways actually a less global sweeping change than simply reducing slot time. And one can get into more details, but that's the gist. So.
Totally fair.
Yeah, and I would say on this particular question, the work of changing the slot time will have to be done even if we do 7732.
I agree with you, but I'm saying in terms of
doing it now.
it's one of the, and I know this analogy has come up in various, in various places, but there was a now slightly infamous EIP 7549 from the previous cycle it looked really simple to people, and this now, because of that experience, we all now are, you know, watchful for these things, but the point is, like, the idea is it has that deceptive quality to it, and it's not that it's bad, it's not that it won't have to be done, it's that in terms of it is not nearly the obvious prioritization to get the end result we want. Do that first, because that's the easy, simple thing, and then we do the like tricky little thing the tricky thing of like slot restructuring. It's actually quite a bit easier to have the slot restructuring in certain ways across from one fork to another, to just say, well, now we have a new slot within slot loop because it only affects that as opposed to like a global view of the chain.
And maybe something that I think is a bit missing in the discussion as well is why we want shorter slot time. So perhaps I can take 2 minutes, and could I use your laptop to?
Yeah.
I'll find the proposal that we made for Amsterdam, because I feel beyond like the implementation details that anyways we're going to have to pay at some point. It's really a prioritization problem, and I think that can only be solved by asking ourselves what do we need the most, not today because that's not when Amsterdam ships, but hopefully 9 months from now. So there's a small bucket list of things here. Yeah, so my main catchy phrase is to say shorter slot times make the Ethereum confirmation engine better, and that has just flow-on effects on many different parts of the protocol. So the first one that I think is very important is just UX, so your transaction confirms faster, like you get some kind of tick faster. In particular with 12-second slot times, on average you get confirmation in 6 seconds. I've learned recently from someone at Coinbase that users think there is a problem with their transaction or with whatever they're doing, like on digital interfaces, whenever the system is unresponsive for more than 2 to 4 seconds. And so if we were to halve the slot time to 6 seconds, the average confirmation would be 3 seconds, which puts you like exactly in like the sweet spot of the user not crossing that chasm of feeling like, oh, something went wrong and I need to take action. As the first one. Second one is better censorship resistance, like you have 2 times as many block producers per unit of time, so you have just more opportunities for your transaction to come on chain. I think this is not negligible at all. Another argument is about apps getting just fresher data, like more often their data is refreshed. So for instance, DEXs, they're quoting better prices most of the time, which means that they're losing less value to the outside that has more up-to-date prices, which means that more value stays within the DEX, which means that you have more liquidity providers, which means that the spreads are tighter for users. So you have lower fees on these apps. And you can make similar arguments for any app that relies on some kind of oracle to bring information on chain. You also make the units of work that happen like every 12 seconds smaller. So for instance, block building auctions or networking load, which means that typically it's better for a system to have like smaller, more frequent things happen than bigger, more infrequent things. That's, I think, easy to understand. Another big consumer of shorter slots is interoperability protocols. Like a lot of them rely on just Ethereum producing blocks to confirm things or to settle things that happen like on different domains. And they've told us a lot that shorter slots can be very meaningful. So I think I hear the devs when they say there's been a lot of work on the restructuring, and at this point we should just ship it because we are sick of hearing about it, and I'm also sick of it. So I would really want us to have like restructured things, but I actually think like this is even like going to 6 seconds would be very meaningful in the shortest order possible, which is Amsterdam. And I was more on the camp of actually saying, let's wait until we have our shiny new consensus mechanism that perhaps like Beam Chain will ship to then deliver like these shorter slot times and just like delay that until then. But I actually think like from everything I hear and from all of these arguments that I've tried to list here, that it would be like such a meaningful thing to do in Amsterdam. So that was my like 2-minute propaganda pitch for the update, out of schedule. I think this makes it very valuable to me, and to have these discussions and to accelerate like the work that goes into figuring out like how much work it is for clients to change this, because I do realize that it's a lot of work. Like it's not a one-line change for sure. To also understand for each of the restructuring proposals how they fare with slot times. Like, do they put us in, let's say, corner solutions that then get difficult to come out of? Like, it doesn't seem to be the case, but I think it's meaningful to think about them together. And third, to also, for planning purposes, like we should at some point decide what goes into Amsterdam and commit, because everybody wants short forks that come earlier rather than later. And so, yeah, having these discussions now is just like very important.
Yeah. So one thing I like to add is that the shorter the slot time, the more you have different type of activities in the client overlap. And the more you have these overlap, the more you have resource management problems at the node level. CPU, disk, memory, whatever, garbage collection, memory, database compression, all these kind of things are getting compromised, which we still find. For example, if you're running a dedicated node, but if you're not running a dedicated node, but your node is doing something else as well, that might start to create issues. This is also very language dependent and very operating system dependent. So you start to be in territories where like some languages suffer more than others, and some operating systems are more adapted than others. I don't know where's this boundary. I'm just saying shortening slot times has this kind of effect of more effort needs to be done in the program, in resource management, so that priorities, which just not supported, for example, in many cases. Yeah, that's it.
Also, I think related to Saba, I'm part of some of the home staker communities, and I think there seems to be issues with Australian nodes where they tend to get some inclusion latency on their attestation, even with 12-second slots. So I don't know if like shorter slot time might actually impact those, Australian nodes specifically.
Maybe from Australia.
So Sigma Prime's Australian, and we run nodes in Australia, and there is like a quantifiable difference, like monetary difference. I don't know the numbers off the top of my head though. I imagine shorter slot times would make it worse, like exacerbated, but I don't know to what degree.
Grow the community and then balance out.
Yeah, exactly.
There were some numbers from Nero, from Tony, right, just the other day, and he also measured Australia and Central Europe. Like, you had some comments on it, maybe, like it wasn't. I'm not sure. Somebody discussed it with him on Twitter, but so Tony made the comparison, and there was like a significant. It took much longer, not just in Australia, but generally like longer than we expected to arrive at a 90% throughput. Yeah.
Right. Yeah, I think we need a lot more of his analysis and like precise one. And then, for instance, Shaddai was presenting like optimization for the peer-to-peer network. Hopefully, these are things we can do before Amsterdam, so that even if we are like at 90% confidence, but we feel like we can get to 100% by the time we get there. This is my like a hopeful thinking.
Right now there is the PerfNet and BloatNet, right? And it would be cool to utilize those, or maybe another one, to see also the. And one question there is also like how we want to ratio the gas limit, like whether we just want to keep the same gas per time, or we want to use it to scale as well, basically.
Yeah. So in my view, it is but like the throughput like metrics are you keep them the same, and you just try to make the granularity higher. That's challenging enough. Okay, let's keep it right. Let's not try to. So do you think Starlink will sort of improve this, because their latency that they advertise is like 16 millisecond app? So basically, I think this is a round trip. So one side would be 30. Compared to what? Like compared to going from, for example, from Australia all the way to North America, right? Yeah. So you can do lower so a bit kind of shortcuts, but I wouldn't count on them for setting up. I mean, Starlink could be. I mean, it could change basically the topology of the network in a very viable way.
I tried running Node on Starlink from Indonesia, and it didn't work. Like I had troubles getting peers over Starlink. I tried VPNs, I tried some like networking tweaks, but it didn't really work well.
Yeah, I think you're better off just getting the fiber.
And why do you think that is? Because the advertised latency is so low.
Yeah, I'm not sure. There is some technical issue with just the satellite internet maybe. But I managed
maybe they
to
are censoring you.
Maybe I was censored. Maybe. But I tried VPNs. I tried like somehow to circumvent it. But yeah, I don't have the right answer. But I think it would be interesting to have like Starlink as like some the bandwidth requirement that we can build around. Like that's sort of the limit or so. But also I managed to connect to peers on internet in plane. So I ran a node in a plane, so the satellite is not a problem. It's something with the Starlink. Yeah.
Yep. I guess.
I think there are some lower hanging fruit that someone could do to be more inclusive to those nodes in Australia or elsewhere, and that is, in ConceptShop you could instruct nodes to include other peers in their mesh based on the RTT that they see. So instead of just connecting to like random peers, which might be the closest ones, there could be an RTT or a latency threshold where you're going to connect to two peers that are 100 milliseconds away, two peers that are 200 milliseconds away, and two peers that are, I don't know, 400 or something. And in that case, it doesn't mean that Australia is going to suddenly come closer, but it's going to be more included in more like nodes that are going to be included in meshes of other nodes, and therefore, getting the messages will be equal to anywhere else. And that's a very simple change.
Or EF does its own low orbit constellation of satellites to sort of bridge everyone all around the world.
Yeah, does anyone have anything else?
Are we sending a node to Mars?
Yes, it's in the roadmap.
It's 10 minutes walk time.
Okay, cool. How are we doing on time, Jessup?
We can wrap up now.
Okay. Well, thank you, everybody.
Yeah, thank you everyone for coming. It was definitely helpful for me. I'm hopeful to have at least one Beam Day every year. I was hoping to organize a Beam Week before DevConnect, but a couple things happened. One is that I was told there might be an interop. And the other thing is that I'm expecting a child around that time, so I don't want to commit to it. But yeah, overall, I am expecting to spend more time on the Beam project, and I am hopeful that, again, it will age like fine wine. So, thanks again for the teamwork that's happening behind this. It's amazing to see about 50 to 60 people here from a dozen teams. Thank you.
Thank you.